Problem 52. Consider three different equilibrium mixtures shown in representations 1 through 3 for the reaction A2 plus B2 forms two ABs. Which diagram represents a reaction that has an equilibrium constant of 16? Now, this problem can be done two ways, visually or through calculation. Using either method, we should make sure we know what the molecules in the picture are. The A2s and the B2s are going to be when you have two of the same color attached together. So let's just say the A2s are the red ones and the B2s are the blue ones. Then the ABs are, of course, what you have when the reds and the blues are attached together. So first, let's do it visually. When you have an equilibrium constant of 16, you remember equilibrium constants tell you the ratio of products over reactants. So an equilibrium constant of 16, that's the same thing as 16 over 1. And you got more products than reactants. Okay, this represents products, that represents reactants. So you got more products than reactants. We say the products are favored. So we're looking for the picture that has more of these guys. And looking at reaction mixture 1 here, you only got one product molecule and you got lots of reactant molecules. So it's not this one right here. Let's put an X next to that one. Okay, what about number 2? Here you got 1, 2, 3, 4 product molecules. You got 1, 2, 3, 4 reactant molecules. So you got a roughly equal amounts. I would say no, it's not this one either. Looking at the third one though, you got 1, 2, 3, 4 product molecules and 2 reactant molecules. So I'm going to put a check mark next to this one. So it's going to be reaction mixture 3 here. Check. Now, a perhaps better way to do it would be to calculate the equilibrium constant for all three mixtures and then see which one comes out to 16. And that would obviously be the one. So to do that, you need to know the equation for calculating the equilibrium constant. It's going to be the product concentrations over the reactant concentrations. And the concentrations are always raised to their stoichiometric coefficients. So the product, AB, has a coefficient of 2. So its concentration is going to be squared. And the reactant concentrations are raised to the 1 power because their coefficients are 1 and 1. So here's the equation. And for concentrations, we can plug in the numbers of molecules that we see in the pictures because the number of molecules is proportional to the concentrations. So we count up the molecules of everybody and we plug them into this equation and then we see what we calculate. So let's first do the reaction mixture number 1. I see 1 product molecule and then 4 of the B2s and then 4 of the A2s. So 1 product molecule, that's going to be 1 squared upstairs, and then you have 4 times 4 downstairs. So this is going to reduce to 1 over 16, and that's obviously not equal to 16. For the second one, you got 4 product molecules and then 2 and 2 for the reactant molecules. So that's going to be 4 squared over 2 times 2. That's going to come out to 16 over 4, which is 4. And still, it's not equal to 16. For the third one, we see you got 1, 2, 3, 4 product molecules and then 1 and 1. So you got 4 squared over 1 times 1, and that comes out to 16 over 1, which is 16. And that's it.